Hello colleagues. I'm happy to welcome you to the first part of our big lesson dedicated to the foundation of the entire AI governance system, the lifecycle of an AI system. Because the topic is both expansive and important, we've split it into two parts. In this first lesson, we'll go from the spark of an idea to a fully built and tested product. Together we'll determine whether we should use AI tools at all, and whether we need to build them ourselves. We'll learn the key principles underlying lifecycle governance. We'll examine in detail the first four stages: strategy, planning, development, and testing. And we'll also understand the importance and place of vendor and supplier management processes within the lifecycle. In essence, these two lessons are a guide to our core responsibilities within an AI project. You'll be able to see our key tasks and duties at each stage. And our entire course from here on will be devoted to how to solve those tasks. So please gather your attention, give this video a like, and subscribe to the channel so you don't miss the next lessons. Let's begin. Building reliable and safe AI systems requires a systemic approach that goes far beyond simply writing code. A structured lifecycle is the very foundation that allows us to embed governance processes, risk control, and compliance directly into development. Let's look at the stages it consists of and how it helps us create safe and responsible AI solutions. Here is the map of our path. This is a classical AI system lifecycle model adapted for governance tasks. Let's briefly walk through each stage. Strategy. Everything begins not with code but with the question, why? At this stage we define the business problem, assess whether AI is appropriate, and obtain principled agreement to launch the project. Planning. Here the idea becomes a blueprint. We design the architecture, define data requirements, prepare a detailed work plan, and most important for us, perform an in-depth risk assessment. Development. This is where engineers and data specialists bring the plan to life. They build data pipelines and train and tune models. Testing. Before releasing the system, we subject it to thorough verification. We test not only technical performance but also robustness, fairness, and compliance. Deployment. This is the safe controlled transfer of the tested system into the production environment. Operations and monitoring. At this stage we continuously watch its health, performance, behavior, and security. Evolution. AI systems are not static. At this stage we improve them, retrain them, and add new features. And finally, decommissioning. Nothing is eternal. When a system becomes outdated, irrelevant, or is replaced by a new one, we must shut it down correctly and safely, preserving all necessary data and knowledge. And here I want to make an important note. On the diagram, this path looks strictly linear. That's for ease of understanding. In reality, modern AI development is an iterative, cyclical process. For example, monitoring results in operations may show that a model has begun to degrade. That immediately triggers a new cycle, sending us back to development to retrain the model on fresh data. Or user feedback analysis may reveal the need for a new feature, which sends us back to planning for the next product version. So treat this diagram not as a rigid straight line but as a main route with many feedback loops. Our job is to ensure that each iteration still passes through all necessary checkpoints and reviews. As you can see, it's a logical, sequential path. But simply following the stages isn't enough. For the governance system to work, it must rest on several fundamental principles that run through the entire cycle. Let's look at those principles. The first and main principle is governance by design. This means we don't try to bolt on governance to an already finished system. We embed requirements for safety, ethics, transparency, and control into the architecture and processes from day one. The second is continuous risk assessment. Risk isn't something we assess once during planning and then forget. Risks live and change together with the system. We must constantly identify new threats and reassess existing ones at every stage of the lifecycle. The third is stakeholder engagement. Building AI is a team sport. It involves not only developers but also business owners, legal, security, compliance officers, and of course end users. Our task is to ensure that each of these voices is heard at the right moment. The fourth principle is documentation first. In AI governance there's a rule: what isn't documented doesn't exist. Any important decision, any model change, any test result must be recorded. The fifth principle is data as a governed asset. This means having processes for assessing data quality, provenance and lineage, retention and secure deletion, and handling personal data. And the sixth, cross-cutting principle is ethics as an all-encompassing aspect. We cannot isolate an ethics stage. Questions of fairness, impartiality, transparency, and potential harm must be considered continuously, from formulating the business idea to decommissioning. These 6 principles and 8 lifecycle stages create the structured framework that lets us build reliable and responsible AI systems. Now, armed with this general understanding, let's dive into the details. We'll start with the strategy and justification stage. Before we begin preparing detailed documents, the project team must get honest answers to 2 fundamental questions. Mature organizations involve not only business leaders and technical experts, but also us, AI governance specialists, as well as legal, because this is precisely where the future risk profile is laid down. The first question: is an AI system the only possible tool to solve this task? In a world of tightening AI regulation and high development and maintenance costs, building AI for AI's sake is a direct path to unjustified spending. So the first activity is an alternatives analysis. Can we solve the task with classical statistics, business rules, or standard software? If the answer is yes, then the lifecycle of the AI project ends before it begins. And that's not a failure, it's a success. We've saved the company resources and spared it unnecessary risks. If the decision is that AI is the best tool for us, we face a second strategic choice: will we build the system ourselves or buy a ready-made solution? Building means full control over development, data, and intellectual property, but requires significant resources and time. Buying, fully or partially, for example using a model via API, delivers value faster but shifts technical risks into the realm of third-party risk. How does this affect further work? For the technical team, the content of lifecycle stages changes dramatically. In the buy scenario, development and training are replaced by integration, API configuration, and comprehensive vendor due diligence. For lawyers, the focus shifts from protecting internal intellectual property to carefully crafting contracts, data processing agreements and service-level agreements with vendors and contractors. What changes for us, AI governance specialists? Practically nothing. The scope of our work remains the same. Why? Because all controls, all documentation requirements, the entire risk register, must be implemented regardless of where the system comes from. If something goes wrong, the responsibility still lies with our company. We'll discuss accountability in a dedicated lesson. But remember the main point: buying technology does not buy you freedom from responsibility. Having answered these 2 strategic questions, teams move to preparing the business case and other activities of the first stage. If we conclude that potential benefits from AI outweigh the downsides and there are no viable alternatives, and we've decided how much we will build ourselves, we move on to the core activities of this stage. First, the business case. At this step we assess the solution's potential business value to understand the project's scale and alignment with strategy and principle. Second, we analyze the regulatory landscape. Which laws and standards will apply to our future system? Third, we create the stakeholder map. Who will be the sponsor, user, vendor, or contractor? Who will be affected by this system? The key roles at this stage are primarily strategic rather than technical: the product owner, actively supported by lawyers, compliance and data protection specialists. The output of this stage is not launching the project but a reasoned recommendation to decision makers. Now let's look at our role as AI governance specialists at this first stage. Our work starts right here. We implement governance by design and lay the foundation for our governance system. Here are our key governance and ethics activities at this stage. First, we create the AI System Passport, our project's calling card. At this stage we populate its base sections: purpose and scope of use, what the system will and will never do. Context and use scenarios: who, where, and for what it will be used. The stakeholder map: who the product owner is, who the team is, who is affected. And the Ethics and Impacts section. We conduct an initial analysis and answer the key ethical questions: what unintended harm could occur? Which vulnerable groups could be affected? Second, we initiate the AI Risk Register. This is our primary instrument for working with risks. We create a cross-functional risk team, carry out their initial identification, and enter into it the most critical high-level risks that could make the implementation of the project impossible from the technical, legal, organizational, and ethical sides. This is our preliminary impact assessment, recorded in the correct, scalable format. The detailed procedures for identification, assessment, mitigation, and control of AI system risks, including AI-specific risk categories, we will study in detail in the large block of lessons devoted to risk management. The output of any stage must be thoroughly practical artifacts, products, processes, and documents that enable, or not, the authorized body to approve transition to the next stage, so-called gating. Upon completion of strategy, such documents are the business case. Where personal data are processed, the preliminary data protection impact assessment. The AI system passport containing all baseline project information. And the first edition of the risk register. This package is submitted to the designated decision-making body or role in the company that decides on moving to the next stage. So, the project has a green light. The team now moves to stage 2, planning and design. If strategy was about whether to build the house, here we produce its detailed architectural blueprint. This stage answers the key question: how exactly will this system be built to be safe, effective, and responsible? This is one of the most saturated stages where the technical and governance foundation of the project is laid. The core activities here are performed by the technical team. First, technical architecture and infrastructure design. We define the system's components, how they will interact, and how security, scalability, and resilience will be ensured. Second, we develop the data strategy. We define sources, quality requirements, cleansing and labeling processes, and ensure mechanisms for tracking data provenance. We assess the use and protection of personal data. Third, we conduct preliminary model and approach selection. ML engineers choose classes of algorithms best suited to the task. Fourth, if the prior stage decided to buy components or a full system, this is where vendor selection and due diligence occur. This is far more than price comparison. The technical team runs comprehensive assessments, evaluating the vendor across dozens of parameters, from financial stability to information security standards. Now let's focus on our role in this important process. We don't design the architecture, but we ensure it's designed with governance requirements in mind. First, we organize and oversee the detailed risk assessment. We coordinate the cross-functional team tasked with identifying and describing all potential risks. The risk register becomes a detailed operational document with likelihood, severity, mitigation measures, and owners for each risk. Second, we oversee updates to the AI system passport. We ensure the project team promptly adds critical sections reflecting planning outputs. The model section should link to the approved architecture document. The data section should link to the data management plan. We initiate creation of the human oversight section where, together with the product owner, we describe how and when a person can intervene in the system's operation. Third, where external vendors or contractors are involved, we verify that selection criteria and contracts include audit rights, security and data protection requirements, allocation of responsibility, a safe exit procedure, and contingency plans. All related risks go straight into the third-party risks category of our risk register. At this stage, we translate ethical considerations from theory into practice. We implement the principle of fairness by design. We put the following questions before the team. Have the data sources been analyzed for historical bias? Does the chosen architecture provide a sufficient level of transparency? We record the answers in the relevant sections of the AI system passport. Finally, we verify that the team has developed, and attached as links in the passport, 2 critical plans, the testing and validation strategy and the model management plan. By the end of the stage, we form a gating package, a snapshot of the key documents. It includes the AI System Passport with links to core project documentation and the detailed risk register with mitigation plans for all identified threats. With the detailed plan approved, the project moves into the active technical phase, development and training. At this stage, blueprints and plans become working code and a trained model. The key question here, is the system being built in strict accordance with the approved plan and requirements? The main workload again falls on technical specialists, data engineers, ML engineers, and developers. Core activities include building data pipelines. Automated processes are created to collect, cleanse, transform, and load data required for model training. Feature engineering. From raw data we extract and form the features the model will learn on. Model training and tuning. We conduct training, run experiments with different parameters, and select the best model version. Integration development. We build APIs and interfaces for the future system to interact with other enterprise applications. The result of this stage is not just a prototype but a product ready for testing, a trained model, working data pipelines, and all necessary code. In development, our primary job is continuous monitoring and validation. Our motto here is, document as you go. First, we conduct continuous risk monitoring. We regularly sync with our team and our risk register. Which planned mitigations have been implemented? Have new, unforeseen risks appeared during development? Second, we organize and participate in key accountability and safety tests. Together with the technical team, we conduct these tests. Our task is to ensure they were executed, the results documented, and the relevant reports exist. In the fairness test report we verify how the model behaves across demographic slices and whether there is discrimination. In the security test report we care about the model's resilience to adversarial attacks and other AI-specific vulnerabilities. The ethical aspect again manifests as practical fairness work. If reports show bias, we initiate discussion and ensure the development team applies mitigation techniques. And finally, we update the AI System Passport so it contains the most important information at this point, detailed performance characteristics of the trained model and concise conclusions with links to fairness and security test reports. The gating package for transition from development to testing must convincingly prove that the product meets all initial requirements. This package includes the AI System Passport, accepted by all accountable roles, a comprehensive test report, a user acceptance testing document, and a compliance certification package. So, we already have a trained system that has passed initial checks. But is it ready to face the real world? To answer that, the project enters the testing and validation stage. Its key question is the system truly ready for production use? Here a broad group of specialists joins in, quality engineers, performance engineers, and, critically, end users and domain experts. Core activities at this stage include comprehensive testing of model performance. We check not only standard metrics like accuracy and recall, but also stability across different data slices. Integration testing. We verify how correctly the AI system exchanges data and commands with the enterprise systems it integrates into. Load testing. We subject the system to loads that simulate, or even exceed, real-world usage to ensure it will withstand peak moments without failing. Simulation of attacks and adverse scenarios. A specialized team attempts to break the system, find vulnerabilities, and expose unanticipated scenarios. And a very important step, user acceptance testing. Real users work with the system, performing their everyday tasks, and provide feedback. Is it convenient? Are results understandable? Does it truly help in the job? The output of this stage must be an exhaustive body of evidence that the system functions as intended and does not carry unforeseen problems. At this stage our mission is to conduct final validation from the perspective of risk and compliance. We must obtain irrefutable evidence that all planned controls are truly implemented and working. First, we carry out comprehensive risk validation. We take our risk register and go through every item, especially those with high and critical levels. Our task is to verify that implemented mitigations are indeed effective. We update risk statuses in the register. Second, we initiate and control testing against governance-specific requirements, checks that often get overlooked at this stage. Explainability testing: can the system provide a meaningful explanation for its decisions? Does that explanation meet our requirements? And human-AI interaction testing: how smooth and intuitive is user interaction? Does the user have the ability to easily adjust or override AI decisions as planned in the human oversight section? The ethical aspect here reaches its peak. We must ensure the system is not only technically correct but fair, transparent, and respectful of the user. We pay special attention to feedback from vulnerable user groups during testing. And finally, we finalize the AI System Passport, bringing it to a deployment-ready version. This document becomes the principal final artifact, assembling all evidence of readiness. We attach links to all final test reports, add deployment specifications, and the incident response team contacts. The final gating package before deployment is the most substantial and consequential set of evidence in the entire project. It must demonstrate, beyond doubt, the system's readiness for production. This package includes the AI System Passport accepted by all accountable roles, the comprehensive testing report, the user acceptance testing document, and the compliance certification package. Friends, this concludes the first lesson on the AI System Lifecycle. We've traveled a long road, from a raw idea to a fully tested, documented, and approved AI system ready for launch. We've seen how governance is woven into every step, making the product not only functional but responsible. But the most interesting part lies ahead. In the next lesson, we'll talk about how to launch this system into the real world and how to manage its long and productive life. Thank you for your attention.